Thank you. In general, if you're multiplying two matrices, does AB equal BA? No. Nope. Matrix multiplication is not commutative. The order matters. Okay. If A is the matrix ABCD, what's A transpose?
ACBD.
Yeah. A, C, B, D. So what used to be a row becomes columns, right? So we had a row AB and a row CD. Those become columns, A, B, C, D. Rows become columns and columns become rows. Right. You'll see. True or false, for matrix multiplication AB to be defined, the number of rows in A must equal the number of rows in B. False. Yeah. Yes, yeah, it's the same. The inner dimensions have to match. Yeah. Yeah. Columns have to match the rows. You got it. Okay, so today we're going to learn about arithmetic with matrices. So we'll learn some techniques and methods and also some properties. Okay, so we're going to learn some techniques, how to do arithmetic, and also some properties of arithmetic. Like we saw in the quiz, like matrix multiplication is not commutative. That's a property. So if I want to, I've got 4 matrices up here. C is a vector, but we could also think of it as a matrix that's 3 by 1. So 4 matrices up here. I'm going to calculate all of these things by hand. I'm going to check them with the TI, just that way I can show you how to use your TI to do matrix arithmetic. And that's it. Then I'm going to have you do a bunch of stuff to discover some properties. All right, so A plus 2D. So that's going to be A, which is 210, negative 305, plus 2 times D, which is 111, 111. Okay, so the order of operations remains here, and that we should do the multiplication before we do the addition. So how do you multiply a matrix times a scalar? You multiply every entry in the matrix by the scalar, in this case 2. Yes, they have to be exactly the same dimensions, and you add them component-wise. Right, and we're getting there. Okay, so this is going to become 210, negative 305, plus 222, 222. They have the same dimensions, so I can add them, and I get 4, 3, 2, negative 1, 2, 7. So that covers multiplying a matrix by a scalar and adding matrices. To add, they have to be the exact same dimensions, add component-wise. Okay, if I wanted to add A plus B, 210, negative 305, yeah, you can't do it because they're not the same dimensions. Could you multiply it? This is 3 by 2 and 2 by 2. Yes, you could multiply it. But, and I should have, why did I write it like that? Trying to add them, you can't add them. So, impossible. Okay. All right, so let's just see what happens with these 2 problems when I try to use the TI. Okay, so I have 2 different matrices here. I'm dealing with A and D. I have 2 different matrices. So you know how to enter matrices, right? You just press the matrix button, you go over to the edit, and I'm going to enter matrix A, which is a 3 by 2. So I'll do 2, negative 3, 1, 0, 0, 5. So matrix A is entered. Quit. Go back to the matrix menu, and I'm going to enter, I can put it anywhere, but since it's called D on my paper, I'll put it in D on my calculator so I don't mix it up. So matrix D, whoops, I want to edit it. Matrix, edit matrix D. And I'm going to make this also a 3 by 2. And it's 1, 1, 1, 1, 1, 1. All right, so D is entered. Quit. So now I want to do A plus 2D. So for my home screen, I go to my matrix menu, choose A, plus 2, then go back to your matrix menu, choose D. So we've got A plus 2D, and it does the whole thing for me. 4, 3, 2, negative 1, 2, 7. Sorry, what? The last part? Yeah. So to get A, you go into your matrix menu, matrix, just choose option A when you're in the names menu, A, plus 2, and then I go back into the matrix menu to grab matrix D. So you go second matrix, choose matrix D, you hit enter, and it gives you the answer. Yep. All right, so then let's see what happens if I try to do A plus B, right? B is 1, 2, negative 1, 4. So I have to enter that matrix first. So I go to the matrix menu. I go to edit. Oops, sorry. Matrix, I want to edit matrix B. So I'm going to make this a 2 by 2. And it's 1, 2, negative 1, 4. So I entered my values into matrix B. I quit. And then I just want to try and do A plus B. So you grab A and B from the matrix menu. Matrix A plus matrix B. Yeah, dimension mismatch, right? Because they're not the same size. Okay, so I think you get the idea on how to use your graphing calculator to do this. If you want to multiply two matrices, you just type A times B, right? So let's do this by hand first. If I want to do A times B, I have 2, 1, 0 times negative 3, 0, 5 times B, which is 1, negative 1, 2, 4. Okay, so I'm going to show you two methods to do this. Do whichever one you like. Sometimes one is nicer than another, depending on what matrices you're working with. But you really only have to know one method. So the first method I'm going to show you relates it to a matrix times a vector, right? So we're going to treat each of the columns of the second matrix like a vector, and you just do yeah, you multiply by 2 vectors, and that's going to give you the 2 columns of your answer. So before I start, this is 3 by 2, right? This guy is 2 by 2. So I can multiply them because the inner dimensions match. What's my result going to be? 3 by 2. 3 rows, 2 columns, right? Each column, think of as a vector. It's going to be 2 columns, so you're getting 2 vectors. You get each of those vectors by multiplying your matrix times one of the vector columns of B. Say it again. No. Okay, so let's see. Column 1 of my resulting vector, I'll just put it C1. That's just going to be matrix A times the first column of matrix B. And the way we've been doing this is that we've been using each entry from that vector as a weight on the columns of A. So we're going to have 1 times 2, 1, 0 plus negative 1 times negative 3, 0, 5. Sorry, I'm using round brackets. I'm getting lazy. Okay, so this should be 2 plus 3 is 5. 1 plus 0 is 1, and 0 minus 5 is negative 5. So it's the first column of my answer matrix. The second column of my answer matrix, I'm going to multiply my matrix A times the second column of B, right? Treating that column like a vector, and we know how to do a matrix times a vector. So each of the entries from that second column is going to be a weight on the columns of A. So I'm going to have 2 times 210 plus 4 times negative 305. And we get 4 minus 12, which is negative 8. 2 plus 0 is 2, and 20. Okay. So my final result here is going to be a 3 by 2 matrix, and the columns are 5, 1, negative 5, negative 8, 2, 20. So with this method, you have to calculate each column as its own separate calculation. So method 2, so I like method 1 because it relates what we've been doing to multiplication of a matrix times a vector. It's the exact same thing. We're just getting each result as a column of the answer matrix. This next method I like because it makes the computation a little more compact. Okay, so I'm going to write this out one more time. 210 negative 305 times 1 negative 1 2 4. Okay, so I know my answer is going to be 3 by 2, right? Because I can tell that just by looking at here. This is 3 by 2 times a 2 by 2. The outer dimensions will be a result of 3 by 2. So I can draw sort of the answer ahead of time. And it's going to have 3 rows, 2 columns. So I kind of put blank spaces where the results are going to go. All right, and then you figure out what goes there by multiplying each row of A times each column of B. So if I multiply row 1 times column 1, row 1 times column 1 gives you row 1, column 1 of your answer. Okay. So the way you multiply a row times a column is you imagine picking up the row, pick it up off the paper, turn it 90 degrees, lay it on top of the column. The numbers that line up, you multiply together and you add their results. So the 2 would be on the 1 and the negative 3 on the negative 1. Multiply the things that are on top of each other and add the result. So I have 2 times 1 plus negative 3 times negative 1. Yeah. Yep. All right. So then so then I'm going to work with, if I would do row 1 times column 2, where do you think the result of row 1 times column 2 is going to go in the answer? Row 1, column 2. Yeah. Right. So row 1 times column 2 goes in row 1, column 2. So this is going to be 2 times 2 plus negative 3 times 4. Right? You just imagine picking it up, turn it 90 degrees, put it on top of the column, multiply the things that line up, and add the results. All right. So then I've exhausted. I've done row 1 times all the columns. So I move to row 2. 1, 0, and I work on row 2 times column 1. The result is going to go in row 2, column 1 of the answer. Okay, so right here, row 2, column 1 is this line right here. Second row, first column. Multiply that row times that column, and we have 1 times 1 plus 0 times negative 1. Yeah. And then I move, keep with that row, but move to the next column, right? So I have 1 times 2 plus 0 times 4. Everybody seeing how this works? All right, cool. To finish up, last row times the first column. Third row times the first column is going to go in third row, first column of the answer. So I have 0 times 1 plus 5 times -1. And then you do third row times the second column, 0 times 2 plus 5 times 4. And you see you will get the same thing. You're going to get 5, -8, 1, 2, -5, 20. Okay, b squared. Just think about, what does an exponent mean? Times itself. Yeah, because that's the only way their inner dimensions will match. Yeah. You can only square a square matrix. Yep. So b squared, 1, -1, 2, 4 times 1, -1, 2, 4. How big is what are the dimensions of my resulting matrix going to be? 2 by 2, and I will let you finish that on your own. Yes. But we're going to move on to A transpose here. So A was 210, -305. -305. If I want to take the transpose, it just means take all the rows and make them columns, or similarly take all the columns and make them rows. So this is going to become 2, -3, because it was a row. Now I made it a column. It was the first row. Now it's the first column. Second row becomes the second column, and the third row becomes the third column. All right, B times D. So B is 2 by 2, D is 3 by 2. So this is 2 by 2 times a 3 by 2. Can't do it because the inner dimensions don't match. Okay. C times D, so that's 127 times 111, 111. So that's a 3 by 1 times a 3 by 2. Can't do it. 3 by 1 times 3 by 2. Impossible. Yes. Yeah. Absolutely. Only if the question on the quiz or the test, your homework looked like that. Right. It wouldn't, it's not something you're going to do like routinely. Yep. All right, so that's how to do arithmetic with matrices. Now, your group activities are not just about practicing the arithmetic, because that's like kind of rote and boring, right? But I want you to test each of these statements. We're trying to figure out if the rules of arithmetic that are true for real numbers, like a plus b equals b plus a, right? That's definitely true for real numbers. Is it true for matrices, right? So I've given you a bunch of matrices to work with, plus a couple of scalars. And I want you to test each of these statements and see if it's true. Feel free to use technology if you want to use your graphing calculator to get some of these answers after you've done just a few by hand, just to make sure you understand how to do the mechanics of the arithmetic. Okay? And that's it.